All right, guys, we are finally at the end of complex numbers here. Not at the end of complex numbers. We're at the beginning of complex numbers. What am I talking about? We're finally at the end of this prerequisite chapter where you feel like you've covered everything you ever talked about in Algebra 1 and Algebra 2. So we're going to try and wrap this thing up using complex numbers. So a couple things we got to remember is that the square root of -1 turns into I. Okay, so that means later on we're going to say I squared is an actual -1. And then we have a sequence of those that we talked about in Algebra 2. So how do we use that idea? The square root of 4, you know, is 2. The square root of -1 gives you I. Okay, so we're going to use it the same way we were dealing with before. So maybe use 4 and 6. And what I like to do is say, all right, that's a -1. So I end up with a pair of 2's. 2 times the 4 is 8. We had a -1, so that's I don't need a pair, and then square root 6. So that's how we simplify our radicals to deal with just a couple of those things. It's then called a complex number if you have a real number part and an imaginary part, and we always list the real number part first. It seems a little bit backwards because we want to treat I like any other variable, except when we do this, we want to put it in the end instead of the beginning. Okay, so add and subtract, you're going to treat it just like any other like term. So I'm going to go with 2 minus 6 to get -4, 5 minus -8, so that means plus. So we're going to add and get 13i. So subtraction is usually the only problem there. I did mention that I squared is eventually going to be equal to -1. So when we go to multiply and FOIL some things, this gets a little bit tricky. So remember we have first is 15, outside is minus 30i, inside is plus 6i, and on the end last is minus 12i squared. So when you did this a couple hundred times in Algebra 2, you just learned to cross this out, right? That's -1. So I'm going to make this plus 12, and then I'm ready to put my like terms together, and then my other like terms together. So I have -24 on the I, and in the beginning, I have 15 plus 12, so that's what, 27 minus 24i, listing the real number part first. All right, so one thing that we shielded you from in Algebra 2 is we don't make you deal with this too much, right? These are both square roots, so we can actually multiply these things together. So we want to put an I form before you multiply when we run into these. So this is actually I root 2 times I root 3. So this becomes I squared root 6. I squared is -1, so it's negative root 6. Becomes our final answer. We have a couple things out of the textbook that you can use your graphing calculator to double check any of those items. Again, we're going to ask you to show work when you need to do it, but otherwise you should be just double checking or throwing it through the graphing calculator. It is a lot more work to put it in the calculator like this than it is just to do the problem. So make that judgment based on the amount of time you have to do some things. All right, next thing we have to do is divide. So one thing we've talked about recently is rationalizing the denominators. So if I had over root 2, I had to fix it by saying root 2. Well, here's the tricky one. I now have a square root. It's hidden as an I in the denominator. All right, and I'm going to highlight this part here, monomial. Since you have a monomial, you're going to fix it with a monomial. Okay, the 6 is not a problem. 6 is totally fine. So the only thing you have to do is multiply the top and bottom by I. And then for a monomial, this is normally the solution on how we deal with it. So what do I get on the top? I get 3i plus 5i squared. So we immediately cross that out and make it -5. So I know this has to turn into -5 plus 3i. And in the denominator, I get 6i squared, which makes it -6. Okay, just keep in mind that we can flip-flop some negative signs around here. So if it's a multiple choice, you kind of have to match someone else's answer. Otherwise, we should be okay. All right, so a more complex denominator, okay? More complex, don't freak out, right? It's a binomial, right? If you have a binomial, then we're going to use the conjugate. Okay? So remember, the conjugate means I want to look like the same thing. So 3 and I, instead of minus, I'm going to make it plus. Why do I do that? Well, let's FOIL it and find out what happens with just the denominator. The only thing I'm worried about so far. So 3 times 3 is 9. 3 times I is plus 3i. 3 times negative I is minus 3i. Ooh, isn't that nice? Negative I times positive I is negative I squared. So what happens now is the middle cancels out. This becomes negative 1, so it becomes plus 1. So now my denominator is plain old 10. Oh, that's pretty nice. All right. On the second half of it, we end up with 6 plus 2i. Right? And that was silly, right? Because we noticed that 2 was going to reduce with 10, but now I'm going to reduce all 3 items, pretending that I had taken it back out and turn it into the 2 times the binomial. So we're going to make it 3 plus I over top of 5. There we go. All right, so that's how we deal with binomials. So monomials we fix with monomials. Binomials we fix with binomials. Sorry, getting a little thirsty there, but that's okay because, you know, we're trying to think about when we did this stuff a long time ago. Remember again, the problem is always the denominator. I'm going to use that problem, in this case the conjugate, to fix that problem. So up top we have a straight up real FOIL, and we modeled this on the left. So I hope you realize the only thing we need to do is the first one for the denominator is 4, and then the last one is going to be minus 9i squared. I'm going to quickly change that out and say that eventually I'm going to have a denominator of 13. That's a good thing. For the top, we're going to do a real FOIL. So I get 10 plus 15i plus 2i. And then for last, I got plus 3i squared. Just double check. I feel like I did that quick and I messed something up. 10, 15i, 2i, and 3i squared. Hey, I did it right. Okay. So again, quickly make that negative 3. So I get 10 minus 3 is 7. And then I have 15i plus 2i. So plus 17i. 7, 17, and 13, there's no GCF here. So that means we're all done with that one. Okay, so binomials, we're going to use what's called a conjugate. All right. Complex solutions. All right, so we can use this to solve. Right, this is not a difference of squares because we're adding, so that means we have to solve it differently. So x squared equals negative 49 when we subtract it over. We're then going to take the square root, so x equals plus or minus 7i as we go to get the solution, which means this parabola does not cross over the x-axis because I got an imaginary solution. Right, this can also happen in the quadratic formula. Okay, it happens when the discriminant turns out to be less than 0. That means negative, right? All right, so as we work through here, so negative b plus or minus the square root of b squared minus 4 times a times c, and it's all over 2 times a, which would just be 2. So I get negative 1 plus or minus, so we got 1 minus 4 over 2. So I get negative 1 plus or minus the square root of negative 3 over 2. Now we do have to finish this up because we would simply simplify the radical anyway. So in this case, it becomes I root 3 over 2. All right, so if you're still looking at one more chance at the SATs, I've noticed that they are becoming very stringent about showing this as 2 answers, and where the plus and the minus as 2 separate ones. Okay, just to show that we do have 2 answers. I do not need to see that. I'm quite happy right here at this step, but just keep in mind there are 2 answers there, and SAT-wise, they are making sure that you guys put that connection together, that we have 2 separate answers, a positive and a negative. All right, so that kind of wraps up P6. We get some homework problems on here if you feel up to it. If not, obviously, we're going to do some in class, draw out some questions, and help you out as needed.